The broadcast is now starting. All attendees are in listen-only mode.
Hello and good afternoon. Thank you for joining today's part 4 of our 4-part Infor XA Web Series on Infor Thru-Put. Presenting today will be our resident XA expert, Rick Altenau. All lines are muted throughout the presentation. We ask that you use the question box, and questions will be answered at the end. Without further ado, Rick, show is yours.
All right, thank you, Elsa. Hi, everybody. For the most part, we have a smaller group today. Thru-Put is not necessarily an application that is as wide of an interest to a lot of people, but we have, based on the people that registered, companies that I think could very well take advantage of some of these tools. So thank you for your time. We're going to get into this. I think I know everybody on the call. So if at a certain point when you are sending your messages in or anything, if you want to leave your name, that's fine, but you don't need to. So if there's questions, like Elsa said, please enter a question. And I'm just going to jump into this and see where we go. I don't think I'm going to be talking about any future reflection of where Infor is going today. Everything I'm talking about is real. Everything exists as of right now. But of course, the disclaimer says anything I talk about for the future is not locked in. So the first question that we need to ask, I'm going to walk through this presentation today, and I'm going to start with some general planning criteria. And some of you may find this a little bit of review, that's fine. But for those of you that are considering planning, considering improving your planning areas, I want to make sure that we spend 10 minutes on some of the background and make sure that we understand what some of the prerequisites are. There is nothing fancy about planning. The customer calls up, says, I need this product next Friday. Takes you 3 days to make it. That's fine. That's Friday, Thursday, Wednesday. That means I have to have the components in stock on Wednesday. Good. Takes me 2 days to buy those. I better cut a purchase order by Monday. That by itself is very simple. There's not a lot of complexity. The problem with planning is that it's complex because we have hundreds or thousands of decisions we have to make. If we have 400 open customer orders with 800 line items with all these different dates, it just gets overwhelming. So do we need software to control planning? No, this is a pretty straightforward function. What it does represent, though, is ease of use. We want to be able to recognize that to do this manually is just cumbersome. Very paper intensive, lots of Excel spreadsheets. We need to be able to take that mess and put it into a system that we can better utilize. So the next question always is, or the expectation is, so if I put in material planning, everything gets easier, right? I'm going to get all these wonderful answers. Everything's going to be awesome. Well, I want to clarify right up front. Is advanced planning easier than traditional planning? No, it's not. It does improve the process. It does make it easier to use. But if your business processes aren't accurate, I will give you wrong answers faster, but on a prettier screen. So the bottom line of planning is if your inventory counts are wrong, if your open schedules are wrong, I'm going to give you wrong answers. If I'm working on a production schedule right now, that those orders are dated to be done 2 weeks ago, but we're running behind, how can a planning system plan what you should have done 2 weeks ago? It can't. It has to start today. So we're really talking about what is our core data. I also want to throw out one other point that is always a issue for planning systems. People say, well, my inventory accuracy isn't good enough, or my schedules aren't good enough, so I can't use a planning system. Wait a minute, you're planning today. You're doing it with that bad data. So the idea that you can't implement a planning system because your data is not perfect is false. You are doing it today. The point of better data allows me to lower my inventory, be better responsive to my customers, be more accurate, provide better quality. All of those things are true. But if I have bad inventory information, what am I going to do? Well, instead of making the 50 parts that I need, I better make 75 because I don't know if my inventory is accurate. Well, what you just did with that 75 is you consumed an hour and a half more capacity on your machines. You extended your work in process on the floor. And when you extended your work in process, what did it do for that other order that doesn't have anything to do with this part? It's now an hour and a half further away from being able to be worked on because you're working on something you don't need. So the bottom line is here, we can help you with your planning processes. We can help you move forward no matter what your prerequisites are, but the better we make those prerequisites, the better the system's going to be. And that's basically where I'm going to start with this. We're going to review the prerequisites of a planning system. I'm going to do this fast. For those of you that have seen me do presentations, you've seen my 6 prerequisites, but they are so important that I like to review them again. Then we're going to summarize, this is all of 2 or 3 slides, what the planning systems are right now in XA. And then we're going to talk about Thru-Put. So half or more of this review this hour is going to be on Thru-Put, but I'm setting up the process ahead of time. So what are those planning systems that we were talking about? What does XA do? Well, it's traditional. That's MRP, CRP, capacity requirements planning, MPSP. It's advanced planning. Advanced planning, most of you already own Visual Planner. That's an advanced planner. And then we have advanced constraint-based planning. That's Thru-Put. So those are the 3 planning systems that XA generally supports, but there actually are 2 more. One is a Kanban system. Now, the Kanban itself is an execution system, not a planning system. One of the mistakes many people make with Kanbans is they think once they set it up, it runs itself. No, it executes itself, but it doesn't proactively fix its problems. You should be doing regular reviews of the number of cards, the quantity per card, how many cards are getting pulled. Are you carrying too much inventory? People that are running Kanban systems, the planning is in establishing what the Kanbans are. The execution of a Kanban is what we call lean. So that is what planning is. We support lean processes through MES. So we have it built into XA, but the operation of Kanban is not lean. I'm sorry, is not planning, it's execution. Now, the most common planning system of a lot of my customers is one you may not recognize the acronym, and this isn't really fun when I can't hear you respond, but for any of you who don't know what OSWO means, this is a planning system. This is what it stands for. So if you are running shortage reports, hot sheets, you have a red list. This is my hot list. And then you have a redder list because this is a hotter list. And then you have a hottest list until you need a new list above that because something's hotter than hottest. Then you're dealing with shortage reports. You're dealing with after the fact responses to planning. Obviously, that's not really a planning system, but that's what a lot of people do. And we need to get that corrected. You want to be proactive and looking at what you're going to do tomorrow and the next day, not reactive to why didn't I get that done yesterday. So from an XA standpoint, the planning systems we have are the traditional MRP, CRP, MPSP, Visual Planner, and Thru-Put. We have the lean system in Kanban, but remember the planning part of that is establishing the Kanban, not running it. So with that being said, why do we need a planning system? Why doesn't the system know all of this stuff for me? Well, when you're looking at your shop floor, I'm simplifying this to purchase parts and manufactured parts. There's a lot of combinations. There's drop shipments. There's all sorts of things that could be in between, outside processing, etc. But when you're looking at the processes on the floor, you have a customer loop. You're entering customer orders, you're allocating parts, you're pulling them from inventory, you pick, pack, ship, and invoice. You have a manufacturing loop. You need some components. You pull those parts on the pick, you make the parts, and then you receive manufactured parts in inventory. When you're making those, you need raw material. You have a requirement. You get quotes, you do purchase orders, the vendor ships them to you, you put them in inventory. The common thread to all this is inventory. Now, if you look closely, the red and the blue and the green lines don't cross. the management of inventory is why we need a planning system. All of these have their own lead times. All of these have their own quality requirements. All of these have all the parameters that we know about. And now, how do we manage those orders? We do it through a planning system. In this case, Thru-Put. Now, when you're getting inventory under control, you have raw materials, you have parts. Maybe you have sub-assemblies. One way or another, you have inventory that are by part number. Your finished goods are by part number. Customer orders part number. This whole section in the middle is much more complicated, and it is the black hole. This is stuff that we release out onto the shop floor, and we certainly hope something comes out the other end. And in many customers, it's that kind of hope that happens. We don't even know when something's going to come out. If you want to be able to promise things to customers, this is what we have to get under control. So when we're looking at inventory, we have to remember inventory is not what I have on the shelf right now. That's a piece of it. Inventory to me is what am I going to have on the shelf tomorrow? What am I going to have on the shelf on Friday, next Friday? Because a customer calls me up, I need to tell them something's going to be available at a given time. So when you're looking at this slide, this is a bill of material laying on its side. A is made up of B, C, and D. A B is made up of an E and F. And E and F are purchased. So I have lead times on here. I can see it only takes me 2 days to make an A. So if I'm going to make an A on the 29th, on the 27th, I'm going to start it. Well, that means these parts are due to inventory on the 27th, so I can start my A. So they already have to be in stock. Well, it only takes me a day to get a C. That's a purchase part. A D I make from a G, that takes me 2 days. It takes me 3 days to buy a G. So you can see this whole thing laying on its side. I define a manufacturing lead time here of 2 days. I define a purchase lead time of F of 6 days. But my cumulative material lead time for an A is 11 days. That's what that number means. And you're manufacturing that. And that's an important field in planning. In theory, I should be able to promise an unlimited number of part A beyond 11 days. Because I can buy the whole thing in that time frame. That might be really good. What happens though if part F comes from China? I know China supplied parts are dirty words right now with everything going on, but let's say it does. It takes 30 days on a boat. It takes a customer over there 60 days to make it. I have a 90-day lead time for an F. Well, all of a sudden my cumulative material lead time there becomes 95 days. So when we're looking at these things, these can be very important. How do you eliminate that? Well, you make sure you have enough stock of F so that my cumulative material lead time, I never have to take A and F into account. I can manage it out 7 days and I'm all set, even though I have a 90-day lead time part. It's all of how we do our planning. So what is planning? We have prerequisites. If I have all the prerequisites done, I can literally implement planning in a couple of days. It's not a big deal. The hard part of implementing is the prerequisites. So let's go through this fairly quickly. You have any questions on this? You can talk to me. Number one, inventory accuracy. How many do I have on the shelf? And it has to be accurate in the computer because the computer is what's doing the analysis. So I need my computer to be accurate and on time. If something is wrong, what kind of effect does it have? Well, look at this. Let's say I have 95% service level. I'm proud of myself. I have 95% inventory accuracy. I have a relatively simple bill here. One part has 3 components. 2 of those components have a couple more components. I have 95% inventory accuracy. That tells me that 95% of the time, the inventory of my parts are accurate in the computer. Through this simple bill of material with 95% inventory accuracy, only 73% of the time are all these parts accurate. 1 out of 4, I have an inventory error in this bill of material. Now, if it happens to be a nut or a bolt and it's no big deal, fine. But what happens if it's one of your key components? How are you managing that? So this is something that you have to keep in mind. I'm proud at 95%. but the more accurate, the better. So that was number one. Number two, bill of material accuracy. Same bill of material as we just saw on the last slide. If I need to make an A and my bill of material is not accurate, I'm not going to be buying the right components. So that's pretty straightforward. Most of my customers do a good job with that. Number three, scheduling accuracy. This is for customer orders, manufacturing orders, purchase orders, inter-site orders, blanket orders, repetitive schedules, planned orders, Kanbans. All of them have schedules. If I am printing out a list of open purchase orders right now, and I have 15 purchase orders that have line items on it with past due components, what's a planning system going to do? Well, let's see, I really need component B. Oh, look, I'm going to get 100 component Bs last week. What's a planning system going to do? It's going to say, okay, that means it will be here by today. So it's going to assume it's here and it's going to move forward. So scheduling accuracy is not just your manufacturing, it's not just your customer orders, it's your incoming orders. A manufacturing order, the start date is the due date of the components. The due date is a promise of inventory. A purchase order dock date is a promise of inventory. Your planning systems are going to use that inventory. Number four, demand management. A lot of customers simply use customer orders. They let customer orders fall through, but there's other sources of demand. What happens if you have a seasonal product? What happens if you make lawnmowers? You sell 80% of your lawnmowers in 4 months. You have so much capacity, so much demand for lawnmowers, there's no way you can make lawnmowers in that 4-month period. You have to make them throughout the year. So you have to take not just your customer orders, but your overall demand and put it out over a time frame. Other demand is safety stock. Other demand is lot sizing. I have to make these 2 at a time. I have a mold that makes 2 at a time. So if I need 1, I'm going to make 2. You just adjusted your demand. So all of those things come into play. So you have to have accurate demand. What am I going to need in the future? Number 5, this is operation control, shop floor. This is advanced planning. This is not a prereq of traditional MRP. Traditional MRP uses standard lead times. Advanced planning uses actual open work orders and looks at the routers and determines when parts are going to get done. So it is actually looking at those routing operations, not standard lead time, to calculate your lead time of manufactured parts. So our routers have to be accurate. Not only do they have to be accurate, but we have to be reporting against them. If I have an open order, it's going to take me 2 weeks to make, and there's 10 routing steps on it. Notice I did my math, so it works out real easy. On day 6, I should be on my 6th routing operation. If I'm not, I'm running behind. So that's number 5. Number 6 then is all the things we think about. The system needs to know, hey, I buy this from this vendor. It takes me a week to get it. Hey, I make these a dozen at a time. Whatever your parameters are, you have to fill in all the things the system knows about so it matches what you already know in your head. Those are the 6 planning parameters. Here it is summarized on one screen. If you have accuracy in these 6 things, we're ready to implement planning. If you don't, we may still be implementing planning, but we should be working on the accuracy of this information. This may be the single most important screen in this whole presentation. For those of you that are watching, you're going to get a copy of this presentation, but this is the screen that if you're considering moving forward, are all 6 of these accurate? That is key. Then what is the result of a planning application? Well, geez, you're running MRP. The result of a planning application is planned orders. Now you're going to be running advanced planning or Thru-Put. What's the result of those planning systems? Planned orders. Same thing. There's 4 fields. What part you need to make, when do you need it, when do I have to start it in order to get it done by my lead time, and how many do I need? That's it. There's 4 fields. Planning's so easy. It's not complicated. So, advanced planning in XA. It's a visual process. Both Visual Planner and Thru-Put is a visual process. We can see these graphical screens. We need to implement that plan that you're developing in the system. The key to both of these systems, Visual and Thru-Put, is you need a master scheduler. That might be new news to some people, but master scheduling is key to making this work. Most of our planners are still going to be dealing with planned orders the way they always have under MRP. Their job doesn't change much because they are releasing and managing planned orders. But now, because you're under an advanced planner, those planned orders should be more realistic. We know we have capacity. We know we have the material available. They should be then releasing orders and processing rather than expediting and competing with each other. We're going to get into these screens. We'll walk through it in a second. So let me introduce you to our planning functions inside the system. Here I'm going to do a quick comparison of the three: traditional, advanced with Visual Planner, advanced with Thru-Put. Here is a traditional top-down, backwards scheduled planning system. Here's what most people do. They have demand, which is either a forecast or a customer order. Now, forecast might be something as simple as I use this many a month. It doesn't need to be a formal forecasting system, but one way or another, we have demand. That demand combines with our on-hand inventory and creates a material plan. That's an MRP. This is the most basic way of doing planning. When you run that MRP, notice I have people in here and I have computers in here sitting inside the data. I run a forecast, I get data, and then I have people to massage it. I enter customer orders, I get data, and then I have people that schedule it and massage it. I have existing inventory doing inventory transactions and making sure it's current. That feeds to a material plan. I run MRP, I get planned orders, and I have planners that massage it. The master schedule here, in many cases, is simply an automated combination of these functions. Now, once I have a material plan, I release it, it goes to execution. I release it as orders. Once I have an order, it's no longer a plan, it's execution. Once you release an order, in theory, it's frozen. You shouldn't be maintaining released orders. You release it for a date and a time because that's when you need it. So that's what a frozen plan is. Down here, it's a released order. As long as it's still planning, it's an MRP and it's a planned order. Now, this is the simplest way of looking at it. Some people have additional requirements. They might want to manually run a master schedule. They might want to take over it. So this is optional, but they can do a master schedule. Master schedule has the ability to do rough cut, also optional. Then maybe with a material plan, they need to understand the capacity so they can run CRP. So this can get more complicated, but all these dotted lines represent batch jobs. And so it's very cumbersome, a lot of overnight runs to get that to work. But this is traditional top-down planning. Now, the key here is I start with customer orders and I backward schedule through my material plan. I know what my due date is, I'm backward scheduling. So I need something next Friday. It's going to take me a week to make it. I have to start it this Friday. Every one of you has seen a requirement that you need to expedite because a planned order says, in order to finish this on time, all you have to do is order this part last week. It's simply telling you what you've already told it. It takes me a week to make the manufactured part, 2 weeks to get a purchase part. So if I take an order for that part due 2 weeks from Friday and I don't have any of the inventory, it's going to say in order to get that on time, all you have to do is order the purchase parts last week. So you are taking orders inside your cumulative material lead time. That's how that all ties together. Now, this is traditional. What happens if I want to do advanced planner? You see all the stuff in the middle here that's batch jobs? When I go to an advanced planner, visual, look what happens. That all goes away. It's replaced with one interactive PC program. However, notice my master schedule is no longer optional. The person that runs Visual Planner is a master scheduler. That's important. Planners continue using the same planned orders as before, but the orders make more sense. Notice for the first time also that there are not people, all these people exist in the disk, in the data, after it's processed. Now I have a person inside the process because I can schedule and manipulate and drag and drop while I'm doing my planning. So I have more controls. Now, if I'm doing throughput, notice what happens. All of a sudden, I have blue lines coming up from the bottom. Up till now, I've been only going down. I'm going to back up. I'm going to do that again. So what I had here in Visual Planner, I have customer orders, forecast, inventory. It goes down. I create my master schedule, my material, my capacity plan. It goes down, and I release orders into execution. That's because I'm backward scheduling from my demand date. What does constraint-based planning do? It forward schedules from your availability to make a part. I don't really care that you want that part next Friday. If the machine that makes it is fully booked, you're not going to get it. So the due date becomes a goal. But I'm going to start from today, calculate when you're going to be done. If I start today, when is my material going to be here? Based on that, what is my capacity on the machines? So what I do is I take that visual planner screen that you're looking at now, and when I go to the throughput screen, it now feeds back from all the open orders back into planning, and I actually reschedule my customer orders. Important statement. Up until now, my due date of the customer order was biblical. I could not change it. Throughput, on the other hand, is going to tell you, you know, whatever you put on there is fine, but here's when you're actually going to get it. So now, if you need it earlier based on customer demand, you have to manipulate something. You have to work overtime. You have to work a Saturday. You have to outsource something. You have to move another order around to free up capacity because I am forward scheduling in Thru-Put. Now, Thru-Put also has a planning workbench, which none of the other planning systems do. So when you are in customer service and a customer says, hey, can I have this by next Friday? They actually have the ability to plug it in and see if you have the resources to do it. That's something you can't do in Visual Planner or MRP. In MRP and Visual Planner, we have available to promise. In Thru-Put, we have capable to promise. So here's a quick summary of what I just said. I'm not going to repeat it because I've said all that, but I have MRP versus Visual Planner versus Thru-Put. And in Thru-Put, we have capacity analysis that gives us a capable to promise capability. So 2 slides on Visual Planner because it is an advanced planner. When I run Visual Planner, remember it's still using a master schedule, it's still using customer orders as my due date. It calculates all the routing operations and it tells me if I have capacity. That's what it's doing right here. And it's saying, man, these are work centers. In your assembly department, you don't have enough capacity based on your customer backlog. It's simply not there. So you have to do something. Now, in my particular case, I have other assembly departments that are maybe not as automated, but they have available time. But it's telling me I have a problem. And so if I wanted to look at what orders are in there that I have capacity problems, I can go to it. You see, here's my order, but this up here is all assembly 1F. And all these colored boxes represent orders. So we can get into all that at another point. Today's about Thru-Put. The way Visual Planner works, it still starts with the due date and it tells me where my capacity problems are, but it doesn't do anything about it. Now, what about Thru-Put? Restraint-based planning. Pretty much on schedule, about 25 minutes into this. I told you I was going to get into Thru-Put in the second half. That's what we're doing now for the rest of the presentation. So, we are an advanced planner. It's constraint-based planning. And constraint-based planning looks at your customer demands and forecasts. It looks at your on-hand inventories, and it looks at your manufacturing capabilities, not at a standard lead time. And by capabilities, I mean available time on your shop. It is based on Eli Goldratt's book, The Goal. If you've never read it, it's very interesting. It is a goal about manufacturing that has everything. It's about a master scheduler and his sons in the Boy Scouts. And it's an interesting book. I've obviously read it a couple times. And what it does is it describes a theory that I'm going to go into in a minute that is usually defined as drum buffer rope, but it defines what constraint-based scheduling is. So it's a good recommendation if you haven't read it. Thru-Put, by the way, Goldratt personally recommended Thru-Put. He's no longer with us, but he did personally recommend Thru-Put as the only piece of software that truly followed all his parameters in the goal. It is constraint-based. It's a pull approach. I pull inventory as I need it, rather than making it and putting it in inventory and waiting for it. So it is forward scheduling. It starts with available time now and moves forward and tells you when you're going to be done. It doesn't start with a due date and back up and tells you when you need to start it. So in Thru-Put, you will never get a requirement to start this yesterday. What you're going to get is a statement that says you're not going to meet your due date. It's not going to be ready till this date. It manages buffer inventory. That's an important statement. I will show you graphically what that means in a minute. But it recognizes there are certain areas that need buffers. The thing for you to think about is on your shop floor, let's say you have a part that goes through 5 manufacturing steps. 4 of those are not the problem, right? You have one machine that's backed up. It is your constraint. How do you make sure that that machine stays constantly running with the right material at the right time? Where do you manage your buffer inventories? I will show you. It's coming up. So the term that is in Goldratt's book is drum buffer rope. What does that mean? I can give you a very straightforward example, but a drum is the pace of your constraints. It puts out a piece once a minute. I can put out 1,000 more manufacturing orders for the components. I can put out 1,000 more customer requirements for the end item. That machine's going to put out 1 a minute. Let's keep that in mind as we're scheduling the rest of our shop floor. Where our buffer is going to be, and I'll show you what a rope is. In fact, I'm going to show you right now. So here is a manufacturing order. Customer needs this part. There's 6 processes in this part. Notice these are not constraints. This one doesn't say it. This is my constraint. So this is the guy that's limiting me. This is where my inventory is buffer. And by the way, constraints can move. I might fix this today and next week, this is my constraint. But let's keep this simple for understanding purposes right now. So what is drum buffer rope? Let's go through this, and we want to remove the constraint as a scheduling problem. We want to base our scheduling on it. So if our schedule is based on the constraint, it's no longer a constraint because I am not over scheduling that constraint. What does that mean? If I have a requirement, I don't care what inventory is coming out of here. I don't care what inventory is coming out of here. I can promise the requirement based on demand going through my constraint. So I'm connecting demand here back to my constraint. That's the rope. I want to pull material through the constraint to meet customer demand. These guys, maybe for every 8 hours I run this, I only run this 4. Maybe I only run this 2. I've got plenty of capacity. If I can get it through here, I know what my schedule is. So the rope takes my demand, skips through my processes to where my constraint is. The constraint then is the drum beat, drum buffer rope. Remember, drum, boom, 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 boom. This is how many I can make. No matter what I'm doing anywhere else, I want to schedule around the constraint. I never want the constraint to go down, no matter what happens. Now, I don't have a constraint back here, but that doesn't mean I want a piece coming out of here and drop in here. What happens if a tool breaks? What happens if this machine goes down temporarily? What am I going to do? I am going to, well, I just got ahead of myself. From the constraint, I'm going to tie another rope back to the first. I want to release parts going into my first work center at the same pace here. But like I said, now I'm getting to where I just said, I don't want to ever run out of parts here. So what do? This is where I build a buffer. I have safety stock out here. I have safety stock here because when I need it, I need to pull it in. But in this entire process, I should not have any buffer inventory. It should pull right through. The only time I have buffer is to make sure my constraint never goes down. This is the theory behind Thru-Put. It's managing the manufacturing processes, not just the due date of the part based on the customer requirement. It's managing my capacity through the facility. So how does that look inside of Thru-Put? Well, here's a similar screen to what I saw before for Visual Planner. Here's my work centers. Here is my capacity going across the top. Notice I have some constraint issues on these things. On these, I do not. But I can identify what those things are. Identify the constraints. The yellow, by the way, is setup. So I'm still consuming my machine, but I'm not making parts. But you can see I'm over capacity on 2 work centers. So with that, I've identified my initial constraints. Remember, this can change on a regular basis. Now, if I take this, remember, I want to forward schedule. So I don't want to take the due date of the customer order. I want to know when can I realistically get this stuff done. It uses those due dates for priorities, but it doesn't restrict me to those due dates. I'm going to take this and I'm going to lay it out on a schedule. So if I lay it out on a schedule right now, this is what it looks like. This is not very realistic. That blue line right there represents my capacity. But I haven't applied my constraint process yet. And you can see, like most of us, because we do have past due requirements, I cannot schedule before today's date. Since I can't schedule before today's date, but I have due dates out there on customer orders that are unrealistic, what's going to happen? It's going to accumulate all sorts of requirements here for today. Now, what is Thru-Put going to do? Well, what is Thru-Put going to do with this? It's going to say, what's a realistic schedule? I want you to reschedule all this automatically based on my capacity and tell me when things are going to be done. And when I push that button, look what it does. Now, I just went to a bigger screen, but here it is. There's my capacity. Notice nothing is above my capacity now. By the way, all the red squares are past due based on the customer order. We don't lose management of the customer order. We just aren't going to lie to the system and tell you that something's going to be done because that's the due date. So we have a lot of past due here. Now, there are all sorts of tools that you can do. It's looking at job steps and all sorts of things here. But one of the things I can do is say, look, I have my restraint work center and I have setup time. I still need to take advantage of grouping product to minimize setup. It's just a reality of manufacturing. So there's things I can do. In this particular case, I went in and said, look, if I'm using the same part with the same setup over a 3-day window, combine them, make them at once. So it takes logic like that into play when it does these calculations. But here I have the main result of Thru-Put. It's going to give me a realistic schedule based on my routers. Because of that, what do I tell my customers? Well, up till now, I've had this thing called available to promise. And what did available to promise do, whether I was running MRP or Visual Planner? And look at the production plan that was out there. It used my standard lead times. But hey, if I had orders released, it would basically look at those orders, allocate the parts, and say, normal lead time's 2 weeks, but I have an order coming in this Friday. Of that order coming in this Friday, 70 parts are available that are going to stock. So of this order for 100, I can make 70 available this Friday and 30 more available in 2 weeks. There, that's available to promise. That's the only thing it does. It uses the last MRP run, the last Visual Planner run to calculate available to promise. Thru-Put, though, is much more complicated and much more thorough. I have capable to promise, and I can actually allocate and reserve capacity to a customer order immediately without waiting for another MRP run. The customer service workbench, that's what this is. Allows me to put in a part number, a quantity, and I can do normal scheduling allocations. I can use aggressive allocations, which changes the rules. How do I move other parts around? And in this particular case, I said this part, calculate when this can be successfully run. And if I put in a due date here that cannot be successful, it will say unsuccessful. So now I got a bigger screen to show you that. So anyway, that is a customer service workbench. One of the first times that we have an interaction to the sales department, and if I say, okay, I'm going to reserve this time for this order, I'm taking this order right now at 2 o'clock, when another inside salesperson comes along at 2:30 and tries to enter another order, that time's already taken. It is reserved. So capable to promise involves time phasing. It includes raw material availability or component availability and capacity availability before it promises that you can make this commitment. So yes, it does do a material allocation. It looks at my requirements for material, my replenishments of material, determines how much I'm going to have on hand, and determines when I can start making this product. With that, then it looks at labor calculations. Notice I have available time mixed in here in my schedule. It's going to figure out if I can allocate that time or not, and it is going to go out there and include that in my capable to promise. So it gives you accurate due dates, not just based on standard lead times, but based on actual capacity. It loads the current snapshot of supply and demand. That's from your last throughput run. It allows you to quote capacity, and we will then reserve that if you tell it to, so that capacity is no longer available for somebody else. That's what it says. It will consume available capacity. Takes into consideration incremental capacity, et cetera. So all the things that you want calculated, a lot more detail than we're going to get into in a 1-hour presentation, but it looks at a great deal of material. It allows you to run in 2 different modes. It can check capacity, like available to promise and raw materials, but in interactive mode, it allows us, that's in batch mode. That's what available to promise is. In interactive mode, it allows us to actually go out and allocate and reserve time. So we can do what ifs. You can go into the customer service workbench, enter something, and not reserve time. Now remember, if you don't reserve it, in 15 minutes, somebody else might have taken it. But as of right now, I can quote this. I can do what ifs. I can allocate capacity by customer. And I can quote the specific dates that it promises me back as it's going through not just a single level, it is looking at the requirements of my bill. Check the capacity and material for the entire bill of material. Again, MRP and Visual Planner peg, and they go 1 level. Thru-Put looks at the entire bill of material. Reflects genuine requirements with quantity and date. It's looking what's actually out there now. It's not looking at standard lead times. And with that, we can get a closer relationship with our customer because we can promise them what's going to be happening. And by the way, as capacity changes, I can verify that we're remaining on time or we're getting delayed, so I can keep my customers up to date. So here's a closer look at a customer service workbench. It's the same screen I saw before, but it's just being able to read it. I would go in here and put in a part, put in a quantity, put in a due date that the customer wants it. The system is going to calculate these things. Remember, I can reserve time for customers and things like that. I hit the enter button. It's going to tell me whether I can be successful with that or not, or it's going to tell me what date I can quote. So it is going to use a capable to promise, not an available to promise. If I am going to do this as a quote and I want to reserve it, I can put an expiration. So if you don't turn this quote into an order by tomorrow, by next week, I'm going to unreserve what I put in here. So the last part about this, and this is getting out of Thru-Put, but this is important. What is Thru-Put measuring for you? It is measuring shop floor execution. If you are not interactive on your shop floor, if you're not using MES, or if you're not using a tool, for instance, from Guide for Scan and Track, that is collecting labor, and I mean online. I don't want to fill out labor cards and turn them in, because I'm doing interactive quoting in the sales department. How does the sales department know what my current status is? I need to have the data online from my shop floor. So we need a manufacturing execution system that's online. We want to eliminate paper from the floor. As I finish a routing operation, I want to code it complete so that my Thru-Put system understands that it's closed. MES allows you to manage those day-to-day processes. I've got a couple slides here on MES, so I'm just going to run through this real quick, but this is important. When you're running a planning system, these are all the standard XA functionalities that we do. When you're running a planning system, planning and material scheduling comes out of, in this case, Thru-Put. What's missing? The feedback from the shop floor. We need to know the status of those routers. We need to know that we are on time on the floor. We're not scheduling based on a due date of the manufacturing order. We're scheduling based on the routing times and the quantities that are on those orders. So it's very important that it's accurate. How do all these things fit together? Well, if I'm running MES and I'm running Thru-Put, Thru-Put is a batch job. I download it, I upload it, it's from my PC. It's doing MPS, MRP, and capacity interactively, but I'm still running a batch job. I'm doing a scheduling run once a day. You can do it more than once a day, once a week, however often you're doing it, but it's doing this calculation once a week. But I'm also taking XA and I'm feeding it to MES, and I'm getting that information back. That closed loop allows me to keep my manufacturing in sync. What does MES look like? It can look like a number of things. You can still be running the old MDCC program. That's fine. You're still interactive on your floor. Here's MES down here. I don't care if you're doing transactions on green screen. I put that up there facetiously. I also have IDF, of course, here. I have barcode. I have interactive. Again, I don't care if I'm on a phone and doing a transaction. This is a picture of Scan and Track up here in the top left corner. The bottom line is how you're communicating to the floor, I don't care. But I do need interactive information. Once you release an order out of Thru-Put, remember, my planners still have the same information. They have a manufacturing order, there's a start date, they have a due date. Now, all the routing operations also have start and due dates. You may never have paid attention to them before, but they are there. And so we want to make sure that we update our database to make sure that they are accurate. But what happens on the shop floor is when we release an order, we get a production schedule. This is for Work Center 9000. Here are the orders, and notice there's a Kanban order mixed in there. These are the orders ready to run on Work Center 9000. I need to make sure these are staying on time, and I can manage this through MES. On the shop floor, I can reschedule and move these things around. This is a function of MES too. But these are released orders. It's important that you remember managing and scheduling a released order is not material planning. Those are planned orders. That's coming out of MRP or Thru-Put. By the way, on the shop floor, the red orders are running late. The green orders are on time. I'm looking at Work Center 9000 and 8000. Who knows? Maybe they're both welding operations. I wanted to look at them side by side. I can actually drag and drop on this. If you've never done this in MES, this order here or this order here is much more important than this down here. I could grab that, or it's PowerPoint, so I can't do it. But I could grab that order, slide it in here, and it would reschedule it interactively. And that previous screen that I'll bounce back to now would then reflect whatever I just changed. All paperless. And of course, I mentioned that there were Kanbans in there too. It would be great if we had a Kanban production line that never had any orders on it, and I only ran Kanban. That is an ideal situation. It's not very realistic. Most of the time, most of my customers that are running Kanbans have them intermixed with manufacturing orders. And that's exactly, if I back up, what this shows. I have a Kanban requirement here that's going through Workcenter 9000. Now, this is a manufacturing order and a routing operation. This is a Kanban requirement. Either way, it needs to be scheduled, and it's going to consume capacity on Workcenter 9000. So I need to know about it. Going back down 2 slides. This in MES is where I set up my Kanbans. I'm not going to go into all the hows and wherefores and what the configurations are, but electronic Kanban is a part of MES. And if we do it right, a Kanban, as it triggers a replenishment, will consume capacity and throughput. So where am I going on this? Improved external supply chain performance. There's a marketing line if I ever heard one. Increase market share, improve relations. You can tell I copied this slide. It's a summary slide, and it's marketing, the benefits. I'm talking about the actual production capabilities and tracking on your shop floor. So as we're going through some of these closing thought processes, improved internal supply chain performance. Because remember, one work center is supplying the next work center. If I can lower cycle times, I am increasing throughput. Keep that in mind. If I make 50 instead of 75, all the work centers, the 6 work centers I had before in my example, now are making 50% less of that part, which means not only will that part get through my shop faster, but there's more available time on all those work centers to make other parts. A mistake that people make is that I keep running out of this part. I'm going to increase my order quantity. Increasing order quantity only increases usage of the machine, lowers my throughput, lowers my availability of that machine for other parts. All of a sudden, I have plenty of inventory of one part, but I'm out of everything else. Or it's taking me, normally a 5-day lead time, now it's taking me 7, which is slowing down my process again. The lower we can make our runs, that's why we've all heard that the perfect order quantity is 1. It's not always realistic. We have setups, we have other things that go into play, but that gives us the most flexibility in our scheduling processes. We want to provide realistic and intelligent plans. We want to give our planners a list of planned orders that they can simply auto-release. We already know the material is going to be here. We already know the capacity is available. How much time right now are our planners competing with each other? I'm in charge of these product lines. You're in charge of these product lines. They both go through the same work centers. My stuff's more important than yours. I'm going to bump yours out of the way. And then this afternoon, you're going to go out and find out your stuff got bumped. So you bump yours back up and the other guy gets blown out of the way. We compete with each other. Can't tell you the number of times when I'm analyzing times of planners, they're expediting against other people internally. That's because we have a constraint problem and it's not being managed properly. Thru-Put will do that for us. Another marketing slide. All the things that we can improve. By the way, I've seen these improvements. These are real, but this takes a level of commitment. How many times do we implement something 80% and it's close enough? If you walk into one of my clients, I don't even know if he's on the line right now, but one of my clients on the West Coast Aerospace has 2 facilities, almost 500,000 square feet each, catty corner from each other on the same intersection. They have 10,000 parts on the floor at any one time in process. Their inventory accuracy is 99.996%. If you divide that out, that means one of those 10,000 parts on the floor has an inventory accuracy error. Now, if you walk into that facility, you tried to pick up a part and you didn't do a transaction, someone would stop you. And I'm not talking about a policeman on the corner. Somebody standing there running a machine says, you can't just take that. Because they have a discipline a process that helps them stay accurate. And the hardest part about good planning is changing that mindset. We have to manage so that good enough is not good enough. So what are you going to do with this? Understand your prerequisites. Get them as accurate as possible. Talk to us about Thru-Put. Thru-Put is not included in your 10x upgrade, your iOS upgrade that you may have done. This is an add-on product. It is an Infor product, very thoroughly the most complicated and thorough planning product that we have. It works, but it is an investment. It's worth every penny for the companies that use it properly. So with that being said, Shawnee, geez, where did that name come from? Elsa? Holy cow, sorry about that. I've been through the presentation. Are there any questions or anything I can help with?
Let me see here. Shawnee, that's a blast from the past.
Oh, absolutely. For those of you that don't know it, Shawnee was working with Guy, geez, 5, 6, 7 years ago. No clue where that name came from out of my head.
At least. I think 8. She was gone when I was hired.
Yeah, you're right. So is anybody awake out there? Has anybody put in any questions, or did we lose the whole group? Elsa?
I am not seeing any questions come through right now. I think that was a very thorough presentation. So yeah, I mean, with that.
Well, you all know me personally. Please feel free to email me with questions if there's anything we can do to help. Thank you for your time today, and I believe also we may be done.
Sounds good. Thank you all for joining, and I will be sending out the recording later this afternoon or tomorrow morning.
Thanks, everybody.